Hello everyone, welcome to a new video on electric vehicle technology. In this video, we are going to discuss about a design thinking approach on hybrid electric vehicles. So previously we have discussed about what is electric vehicles and its definition, types, key components, advantages, challenges and market trends. So now we are going to see about why we need an HEV. So first let's empathize what are the user needs and their understanding. What are their pain points? The main concern is 3 points. One is the range anxiety and charging infrastructure availability and initial purchase cost. The next is the urban commuters. Focusing on the efficiency in stop and go traffic, compact design, and ease of parking are the expectations of the current IC engine users. And prioritizing emission reduction, sustainable manufacturing, and end of life battery solutions are a major concern kept from the environmental advocates on the IC engine vehicles. Now let's define what are the core user problems. First thing is cost versus value. The current IC engine vehicles are costlier as well as the fossil fuels are becoming extinct. Next is range and infrastructure. It provides quite a good range and it has a better infrastructure also, but it requires an adequate charging access for the HEVs. Next is the performance expectations. As we know, the customer expects a quite a good acceleration and they expect overall good range of vehicles. So, in order to meet all these requirements, what will be the solution? Yes, that is hybrid electric vehicles. Hybrid electric vehicles is a combination of internal combustion engines with an electric propulsion systems. It aims to improve fuel efficiency and reduce emissions. The key components of HEVs are internal combustion engines. As we know, it is a combination, it is hybrid. So it has IC engines as well as EV. That is battery and motor. So it has internal combustion engine, electric motor, battery pack, and power electronics, converters and all, and then the transmission system. The main working principle of the HEV depends on three types. One is series hybrid, parallel hybrid, series parallel hybrid. A series hybrid is the ICE generates electricity to power the motor, wherein which the power will be generated in a series manner. Everything, the drivetrain will be connected in series along with the IC engine as well as the battery. So the IC engine generates power, it will be stored with the battery and then it will be transferred to the powertrain systems. Whereas in parallel hybrid, both the IC and the electric motor directly drive the vehicles. Both will be connected in parallel. So if one it is based on the range requirements and performance requirements, any mode will be selected. Next is the series parallel hybrid. So it is a combination of both series and parallel configurations. So this picture gives the working principle of uh, both EV only and as well as in hybrid mode. In EV only mode, the battery will power the entire systems, whereas in hybrid mode, that is electric assist, the battery along with the internal combustion engine will supply the entire power system, powertrain. When the battery charges, the how the battery will be in the image you see, you can see that during the IC engine drives the powertrain, the battery based on the rotations, the converters will grab the power from that motor. That is, it's like quite of a regeneration mode. That power will be stored in the battery. And in regenerative braking mode, the power from the through the engine from the power from the engine to the motor is not utilized, whereas only the vehicle dynamics, that power will be converted by the motor and it will be stored in the battery through the electronic controllers. So Here, let's discuss the type of HEVs in detail. In series HEV, as we look at the powertrain configuration, every elements will be connected in series. That is, the IC engine along with the battery will be connected in series. Whereas in parallel HEV, you can see the engine and the electric part along with the IC engine part, they are connected in parallel. In series parallel, it is a combination of both. So you have both a series configuration as well as a parallel configurations. This kind of configuration is recently available in Toyota Prius, which is an example of hybrid electric vehicle. So this is a summarization of the classifications of different HEVs. The main benefit of HEV is that it is quite fuel efficient because we use regenerative braking and reduce idling, and we can toggle between the IC engine mode as well as the electric mode. So the usage of the fossil will get reduced drastically. And since that fuel IC engine mode is used in a reduced manner, the low CO2 emissions will also get reduced. And also, it meets the range anxieties also. So, enhanced acceleration with electric motor assist is feasible with the help of HEVs. But even though it has a lot of advantages, it has limitations also. The main thing is cost. In order to incorporate both electric and IC together, the upfront cost will be high compared to the conventional vehicles, and also we need to assist the battery in the design. So additional components will add vehicle weight, and also there is a concern for battery degradation and recycling also. So that is also a biggest threat. Okay, so amidst all these challenges, there is future trends because in order to make it more viable and feasible, current researches are also going on in the challenge areas that we have discussed previously. So that is why many advancements are being carried out in battery technology, and also to give more power, because if we use large number of EVs, of course the grid demand will get increased. So integration with renewable energy will meet out those grid demand. And also enhanced efficiency through intelligent systems is also one of a major future trend in HEVs. So where these HEVs are commonly used as of now in automation industry, yes, vehicles and marines, that is also being now run with the help of HEVs, and in aerospace systems. So with what we have discussed so far, let's have a quick test about your knowledge in HEVs. Which of the following is not typically considered an advantage of HEV? Of course, significant lower purchase price. HEVs are a bit costlier because it combines both IC as well as uh, battery. So it is costlier. Okay. So I hope through this video we have approached 5 stages of DT in analyzing about hybrid electric vehicles. We have empathized why we need HEV, and we defined the problem statement, and then we ideated how HEV will meet out those pain points of the consumers. And in detail, we have discussed about what is HEV, what are the different types, what are the advantages, disadvantages, and where it is used. And finally, we test with a few quiz. I hope through this video we have uh, a clear idea about HEV. In future, we'll discuss a different topic in electric vehicle. Thank you. Thanks for listening.